Hello, welcome back. Today we're going to talk about the rational zero theorem and how we can use this to solve any polynomial function we want, without using a graphing calculator or some other tool to see where we cross the x-axis. This allows us to solve these functions algebraically. In the textbook, we're in section 4.9. Again, that's the Glencoe Algebra 2 2018 edition, page 293. So the way the rational zero theorem works is that if we have a function p of x, then every rational zero of p of x is going to be formed p over q, where p is the factors of the constant term at the end, and q are the factors of the leading coefficient in the front. So, for example, if we have 6x to the fourth plus 22x cubed plus 11x squared minus 80x minus 40, 4/3 will be a factor of it, could be a factor of its solution, because 4 is a factor of the negative 40 and 3 is a factor of the 6 in the front. So what we're going to do is just kind of practice listing these out to see what could have worked. So for here, our constant at the end is 24. So our p-value is all the possible factors of 24. So 1, 2, 3, 4, 6, 8, 12, and 24. We must also remember to list positive and negatives there, because it could be a positive or it could be a negative factor. Both will have to be counted. And then Q is just simply the factors of our leading coefficient, which in this case is just a 1 there, just plus or minus 1. So all our possible zeros then would just simply be, since Q is 1, it's supposed to be P over Q, we'll just simply relist the p-values. So plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Those are our possible zeros. Obviously not all of them will work. It's only a cubed, x-cubed function, but some of those will work. And this is how we go about solving a polynomial function. We want to figure out what are the possible zeros, and then we're going to try out synthetic division until using these different zero possibilities, until we get to a remainder of 0. So it's a lot of guessing and checking, but we want to make sure we at least guess and check with numbers that could work. Like obviously for this function, 10 is impossible, because 10 is not a factor of 24. Whereas a 6 could be a factor. I'm not saying it is. I have no idea if it really is or not. Or 2 or any of those other ones. But we want to list out the possible zeros first, and then guess and check from those numbers. So if we have this function right here, well, our factors of p, the constant term, will be 1, 2, 4, 8, and 16, whereas our factors of q, the leading coefficient, will be 1, 2, and 4. So now our possible zeros, well, what we're going to do is we're going to list all of them originally, the 1, 2, 4, 8, and 16, and we're going to list them out dividing by 1, and all 5 of those divided by 2, and then all 5 of those divided by 4. So we'll have 1, 2, 4, 8, and 16 divided by the 1. And then we can have them divided by 2, so it'll give us a half, 2 over 2, 4 over 2, 8 over 2, and then 16 over 2. And then all of them divided by 4, so 1 over 4, 2 over 4, 4 over 4, 8 over 4, and then 16 over 4. So we have all these different fractions. Now in this particular scenario, a couple fractions have already been listed. So 2 over 2 is a 1, we already listed that, so I don't need to really include that again. 4 over 2 is 2, don't need that. 8 over 2 is 4, 16 over 2 is 8, so I don't need those fractions. But the 1/2 is needed because it wasn't listed earlier. 1/4 is needed because, again, it's not a repeated 0, but 2/4 is a half, 4 over 4 is 1, 8 over 4 is 2, and 16 over 4 is 4. So all we really need is just simply the factors of p, 1, 2, 4, 8, 16, and then the two fractions that are not repeated, the 1/2 and 1/4. Now don't assume all the fractions will always pretty much cancel out. That only happens under special circumstances. Here, since p and q are factors of each other, that's kind of why that happens. if q had been like factors of, we'll say 6, so you'd have 1, 2, 3, and 6, you'd have a bunch of fractions that don't cancel out at all. Now, when you're trying out these different solutions, again, you're guessing and checking. I would suggest starting methodically, either starting at the ends and try the positive and the negative, and then kind of work your way down or up, or you can kind of start in the middle. There's no real rhyme or reason behind where you're going to start at. I have had experience with students who, once they start doing this, getting a little better at it. They're very, very good at guessing them. But I cannot stress enough the importance of making sure you're copying down the problem correctly and all the correct signs and all the correct numbers. Because if you work through this, let's say, for example, we wanted to factor this one, and instead of writing down the negative 2x cubed with synthetic division, you did a positive 2x cubed, and you're getting nothing to work, well, it's because you wrote down the wrong number, and you have to redo the whole problem from there. So please be very careful as you work through these. So for the first one, I'm going to go through the process kind of methodically, starting with our ones and kind of working our way up from there to see until I get to one that doesn't work. So the possible zeros here, since the leading coefficient's a 1, will just be the factors of 12. So 1, 2, 3, 4, 6, and 12. So I'm going to start with a negative 1. We're going to put a 1. Don't forget the 0 for the x squared, negative 13, positive 12. So we carry down the 1, we get negative 1, 1, 12, negative 12, sorry, positive 12, my bad, and then 24. So, unfortunately, that didn't work out for us. So negative 1 is not a solution. But as we can see, it almost worked out for us. So maybe we should try positive 1 then. Maybe that would be okay. 1, 0, negative 13, 12. Well, carry down the 1, 1, 1, 1, negative 12, and 0. So 1 works. So that tells me this would have factored right here to an x minus 1. And then we have an x squared plus x minus 12 left over. Well, if we want to solve this out, we can just simply now factor our quadratic. So we're going to see it's x and x. And then if we're multiplying to be negative 12 and adding to be a positive 1, it's a positive 4 and negative 3. So it gives us solutions of 1, negative 4, positive 3, which if you look back at your possible zeros, all are under that list. So sometimes you can get it right on the first shot, sometimes it'll take you 2 tries, sometimes it'll take you a little bit more. In this particular case, if we had started from the biggest number, 12, and worked our way down, we'd have had to have gone through at least 5 of them before we actually got to final answer. So it all depends. You just always make sure you're careful writing down the signs. Don't forget your 0 placeholders. Just be very careful with the synthetic division. It's a very easy process, but it's also going to be very tedious if you don't happen to guess right quickly. And if you write down the wrong numbers or signs, you're going to be just wrong the whole way. So watch out. Alright, so we have x cubed minus 5x squared minus 4x plus 20. So again, there's a 1 in the leading coefficients. So the only possibilities we have are the factors of 20. So 1, 2, 4, 5, 10, and 20. So I'm going to start off with 5. Again, I know what the answers are, so instead of making this video last forever because we're going through a tedious process, I'm just going to use numbers I know work. So 1, negative 5, negative 4, 20. So we carry down the 1, 5, 0, 0, negative 4, negative 20, 0. Good. So it factored x minus 5, and then x squared minus 4. Well, the x squared minus 4 is the difference of 2 squares, so that will factor as x minus 2 and x plus 2. Which means our solutions would represent positive 5, positive 2, and negative 2. Okay? So again, if you would try this out on your own, if you start with the ones, it would have taken you 3 tries to get to till you got to one that worked. If you started in the middle with the 4, well, then it would definitely take you at least 3 tries going through the 4s, then either getting the 5 or the 2s. It all just depends. So don't get yourself frustrated. Just work through it. It's going to be okay. Just make sure, again, you're methodical about it. Don't cancel out negatives. Don't skip negatives. Do a positive and then a negative. move on to the next number. That if they both don't work. Now, if there's a number in front, we need to consider the fractions. So we're going to have, again, the factors of 28, 1, 2, 4, 7, 14, 28. We also will technically have a 1/2. 2 over 2 will be a 1, so we don't need that. 4 over 2 will be a 2, don't need that. 7 over 2. 14 over 2 is 7, we don't need it. 28 over 2 is 14, don't need that. So those are all the possibilities. Now, a fraction is guaranteed to be an answer with one of these problems. That much I can promise you. I would not recommend, though, trying to use one of the fractions. Generally, synthetic division with a fraction is not work out very nice. It becomes a little more interesting with how you're getting your final answers there, so I would recommend staying away from the fraction. I instead try out the different numbers, 1, 2, 4, 7, 14, or 28. Kind of ignore the fractions pretty much. So as we go through this, if we go try a -2, so we have 2, -7, -8, 28. So we carry down the 2, we get -4, -11, 22, 14, -28, and 0. So there's our quadratic. We have x plus 2 is one factor, and then 2x squared minus 11x plus 14 is the other factor. So now, again, you're going through your grouping method to work it out. I'll just tell you that your answer will be x minus 2, and then 2x minus 7, when you do the full full-line process. Reverse well, sorry. So you get -2, +2, and then +7/2 for your answers. So don't allow there to be a number in front of the x cubed term to freak you out. Just pretty much ignore it. Go through your usual process. Don't worry about the fractions. You'll know that you'll get a fraction in the answer in the final end. It should either be a 1/2 or a 7/2. So you can kind of use that to help you figure out if you want to kind of do a guess and check method instead of the grouping method to factor the resulting quadratic. Kind of recognizing, okay, it's 14, so it's got to be a 7 and a 2 then at this point, because the 14 and the 1, there's no fractions with that, and then it's a matter of where does the 2 go? Does it go with the 2x, or does it go with the 2x minus 7, or the x minus 2 part? Alright, now, where it gets a little more interesting is when we have an x to the 4th function. So we still want to list out all the possible zeros. So with 54, we have 1, 2, 3, 6, 9, 18, 27, and 54. There's a lot of them. That's fine. We still just want to only work with certain ones. So now let's try -3 first. So we do 1, 1, 3, 9, -54. So when we work it out, we get a 1, -3, -2, 6, 9, -27, -18, +54, and 0. So now we have x plus 3 is one factor, but then the other one is x cubed minus 2x squared plus 9x minus 18 is the other factor. Well, shoot, I have a cubic. I need to go do this one more time. The nice thing is, though, we're noticing that our constant term is 18. So that means the factors of 54 and 27 are all not possible anymore. We can only use factors of 18, which are the 1, 2, 3, 6, 9, and 18s. Again, to kind of make our lives a little bit easier, if we use 2 for the next one, we now use the new factor with the new polynomial. So it'll be a 1, -2, 9, -18 we're working with. So as we work it out, so we get a 1, 2, 0, 0, 9, 18, and 0. So this now means we have x plus 3 still. We now have an x minus 2. And the last one is an x squared plus 9. Now we need to be very careful. This is x squared plus 9. This is not a difference of two squares, so this won't in fact be x minus 3 and x plus 3. If you find that you have a sum of two squares, then this will be an imaginary answer. We get imaginary solutions. So we know it's going to be -3 and +2. The other one, though, when we set up x squared plus 9 equal to 0, we get x squared equal to -9. And so again, square roots give us plus or minus. Square root of 9 is 3, and it's got to be 3i because the -9 parts. So plus or minus 3i. So if you recognize that you have a sum of two squares, your answer will always be positive and negative, the square root of the number, and then I. So if it was x squared plus 25, for example, it'd be plus or minus 5i. If it was x squared plus 1, it'd be plus or minus 1i. And that would represent our answers. Okay, so that's how the rational zero theorem works. It's guessing and checking. When you get better at it, you can pretty much kind of lock in on guessing and checking within 1 or 2 tries. Obviously, before that, it might take a little bit longer, and that's okay. So don't stress. Alright, so that's it for this video. Thank you for watching, and I will see you next time.